Welcome to Let's Calculate Something. Today we're going to cover factoring of a trinomial into two binomials, and we're going to spend some time going through a little bit of the theory. Then I'm going to do a couple of examples. Then I'm going to give you a couple of problems that you can do, and I'll pause the video, and then you can work out those problems. And then there's some homework at the end, because as we go through this, you're going to see that this is just requires some practice, and the more practice you do, the quicker you're going to be able to solve these, like for an exam or something. Okay, so let's start by talking a little bit about what we're trying to do. We're trying to take this common form for a quadratic, we're trying to put it into a form of x plus p times x plus q, where p and q are integers, okay? And the way we do this is we look for a common factor of a, b, and c. If there's a common factor, you can divide that out and carry it forward, and I'll show you some examples of that. And then we want to look for the case where there's two different cases, and we kind of handle the problem a little bit differently depending on the value of a. If a equals 1, then we have this method, and we'll talk about that. And if a does not equal 1, we have another method that we have to use. And what we use for a equals 1 is the FOIL method, which is multiplying the first terms, then the outer terms, then the inner, then the last terms. And you should have already covered that, the FOIL method, but we're going to use that not to go in this direction, but we're going to use it to go this direction into factoring it. You'll see that when we go through it. And then when a does not equal 1, we have a couple of ways. One is trial and error, which is, I put a frowny face there because trial and error takes a long time, not as scientific. We're going to try to use some tricks to simplify the trial and error, and we're going to use this using the numbers a and c. We're going to use that method to figure out what the factors are, okay? We're going to show you some tricks, some ways to simplify the work and speed it up. And then the other thing you do is whenever you factor something, you use FOIL to multiply it out to make sure you get back to the same equation you started with, the same trinomial you started with. And then the key is to practice, practice, practice. So let me erase a little bit of this, and I'm going to come back to a couple of problems, and we'll work some examples. Okay, we're going to work on the first expression that we have to factor, and we're going to factor this into x plus p and x plus q, and our trick is to find p and q. And just as a note, the first thing we want to check is a common factor. And in this case, whenever a is 1, which is our case here, there will be no common factors. You can skip that piece. But you might find a common factor that brings a equal to 1. And we'll do an example of that later. But right now, we don't have to look for a common factor. For a equals 1, we have to use FOIL. So what we can say is we know we're going to end up with x plus something times x plus something else. Okay? And we know what we first do is we take this 24 and we break it down into factors. We take c from the equation, we break that into factors. So for 24, we have 24 and 1. It's positive. We note the sign. Okay, it's positive. Okay, so we have 24 and 1. That's one way to get 24. But there's another way to get 24, and that's minus 24 and minus 1, right? Then there's 12 and 1. And then there's minus 12 and minus 1. Then there's 8 and 3. And then there's minus 8 and minus 3. And then there's, 6 and 4. And then there's minus 6 and minus 4. And I think all of those are factors. Now, one of these pairs is going to work for this equation. But which one? The trick is now we have to find a pair that is going to add up to 10. Okay? So of these here, we can see 24 and 1, that's not going to add up to 10. Anything negative isn't going to add up to 10. So the first thing we can do is take off all the negative ones. Take that out, take that out, take that out, and take that out. And that's a positive 10. So if I add two negative numbers together, I'm never going to get a positive number. So that means we can take those out. We don't have to worry about them. And we know 24 plus 1 is not 10. We can take that out. We can take 12 plus 1 out. We can take 8 plus 3 out. What are we left with? 6 and 4. They do add up to 10. So we know x plus 6 and x plus 4. So now let's check our work. We use FOIL. So we have x squared plus 6x. Oh, x squared plus 4x plus 6x plus 24. This is 10x. So we have x squared plus 10x plus 24. And so this is our answer. Okay? So you can see we didn't really use trial and error. We used a trick. We look at this value here. If it's positive, we know we can eliminate the negatives. And then if it's negative, we'll have to do something different. And we're going to see that in the next example. Okay, so let's do a second example. Now we have a negative number here. X is still 1, so we don't have to check for common factors. We're good there. Now we have to find the factors of 6 such that the two of them will add up to minus 5. The factors of minus 6, I'm sorry. So we have minus 6 and 1. We have 6 and minus 1. We have minus 2 and 3. We have positive 2 and minus 3. All of those will add up to, or they will multiply out to be factors of 6. Now, let's find some that add up to minus 5. Okay? So does minus 6 plus 1 equal minus 5? It does. So we got lucky in that one. So we were able to find that's there, and if you were doing this problem on a test or doing this problem quickly, you could stop right there. You found it. But let's just walk through these to prove that none of them are going to work. Okay? Minus 6 and minus 1, that's 5. That's not minus 5. Minus 2 plus minus 3 is 1. 2 plus minus 3 is minus 1. So none of these work. Right? So we know we found the answer. So we could have stopped here, but for clarity, we just wanted to show you. So we know that x minus 6 and x plus 1 will be our factors. And we can multiply that out. X squared plus x minus 6x minus 6. You see these two are equal to minus 5x. And we have x squared minus 5x minus 6. We checked it out. We're done. We got it. It's perfect. So now we'll go to, I'm going to write up 3 examples for you. I'll be right back and we can do a little time test. Welcome back. Okay, so now you've seen 2 examples worked out. We still have a equals 1 on 3 more problems. And what I want you to do is I want you to write these down and pause the video. And then I want you to be able to solve these problems in 3 minutes. Okay? And what we're going to do is when you start the video up again, I'm going to show you the answers to these 3 problems, and then you can check your work, and then you'll see a little moniker come up, and it will tell you what point in the video you should advance to get an explanation of those if you got any of them wrong, right? So you don't have to watch the whole video if you got them right. If you got them all right, you got the concept, you're done. I will then just show you the homework I have for you. I have another 3 or 2 problems for you to do, and it will be good for you to do that and leave your answers in the comment. But we'll get to that later. Let's just go ahead and pause the video and give these a try. Welcome back. How'd you do? I hope you got them done in 3 minutes or less. If not, it's okay. It's more important to get them accurate. So let's see if you did. On the first one, the answer is d minus 3 times d plus 2. On the second one, it's x plus 5 times x minus 3. And on the third one, it's x plus 18 and x minus 3. And what's important here is whenever you see a negative on the C, what do we notice from this? We notice that these terms are going to be different. You're going to have a plus and a minus somewhere on these two. They won't be the same. They won't be both minus. They won't be both plus. They're going to be different. So that's a quick check sometimes when you're doing these. So we talked about some tricks, and that's one of them. So if you got them all right, awesome. You're good. You don't have to do anything else. But I do have a couple of homework problems for you. I want you to factor x squared minus 17x minus 60 as 1. And that will be x squared minus 17x minus 60. That's one problem. And your second problem is m squared minus 13m minus 30. Okay? Do these two problems, go into the comment section of the video, and put your answers. Okay? And then I'll come back and comment and tell you if you got it right or not. And if you didn't, I'm gonna, in a few days, once I have this video out, I see a few people that have answered, I'll put the solutions for these in details in the comments. So just come back with your answer and put it in the comments, okay? So what we'll do is we'll come back in a second. I'm gonna walk through these three problems. And I'll put a little thing up here to tell you where to go for the right answer for this problem. You don't have to watch the whole video. You can jump to that part in the timeline. And let's jump into that. But if you've got them all right, you're done. Thank you for watching, and do your homework and put your answers in the comments. Thank you. All right, let's work this one out. First thing we have to do is look for common factors. We see it's a 1. We don't have to even worry about that. I reinforce that because when we get to the a does not equal 1 case, where this is something bigger than 1, we're going to have to do that every time. So it's a good habit to get into. So let's solve this. We have to find the factors of minus 6. Factors of minus 6, we did this before, are minus 1, or minus 6 and 1, plus 6, and minus 1, 2, and 3. I'm sorry, minus 3, and then minus 2 and 3. Those will be our factors. We have to find the one that adds up to minus 1. Okay, so if we just look quickly, well, that doesn't, and that doesn't. This adds up to a positive 1, so that's wrong. And this one is the 1, because this adds up to a minus 1. So very quickly, we can see we have d plus 2 times d minus 3. So let's check our work. We get d squared, then plus or minus 3d plus 2d minus 6, and that is d squared minus d minus 6. And that's our answer, okay? So that's the first one. Now we'll do the second one. All right, let's solve the second problem. Okay, for this one we have to find factors. So first of all, we have no common factor, and we know that because we have a 1 here. Now what we have to do is find factors of 15. So of minus 15. So we have what? Minus 5 and 3. And then we have 5 and minus 3. Then we have 15 and minus 1. And we have minus 15 and 1. And I think that's all of them, okay? Now what we have to do, which of these add up to positive 2? Okay, so clearly these don't add up to positive 2. We can take those off right away. So we now have to figure out which one of these do. Does minus 5 plus 3, that equals minus 2, so that's not it. And then 5 plus minus 3, that does equal 2. So we have x plus 5 times x minus 3. And then if we FOIL it out, we have x squared, right, minus 3x plus 5x minus 15. So we have x squared plus 2x minus 15. Same thing as what we started with. That's our answer. So that's the answer to number 2. Now we'll go on to number 3. Okay, so the third example, we have a pretty gnarly number here, 54. We're going to talk about how to walk through that, okay? So we know a is 1, so we don't have to worry about common factors. We do have to unpack this 54 and look for its factors, okay? So the way I like to do it is once I see a number is even, I know 2 is a factor automatically. So we could start there. And everything has 1 as a factor. So you have something to work with right away, okay? So let's walk through it. So we know we have to look for minus 54, and that's minus 1 and 54. Those are factors. And then plus 1 and minus 54, those are factors, okay? 2, if we look at 2, we know minus 27 is a factor, right? Because 2 times 27 is 54. And then, so that means we got to look at minus 2 and positive 27. And then if we look at 3, how does 3 divide into 54? Well, we know that it's 1, it will go into 5 once, and then there's 24, so it's 18. So we know we have 3 and minus 18, and then we have minus 3 and plus 18. And 4, if we divide 4 into there, it's not even. I think it's like we have 1 and we have to divide 4 into 14. We know that doesn't work. And then 5 doesn't work. That's easy to see. And then 6, would 6 work? Nothing times 6 equals 54, integer-wise. And then 7, now we're up to, some numbers like 7 times 7 is 49, 7 times 8 is 56. So we're out of the range. So we know if we keep going, we're going to start to run into, it's just not going to make sense, right? So we're done factoring. So we know once we got to 3, we have 6 things to try. Now what we have to do is find the one that adds up to 15, okay? And so these we could eliminate right away, because 54 plus 1 minus 1, that's not going to be 15. And 2 and 27, we could see that's not going to add up to 15. Now we have to look at these two. This is where you have to be careful with the signs. We have to look at the signs. We need a plus 15 here, okay? So 3 plus minus 18 is minus 15, so that's not it. So we automatically know we got it, but let's double check. Minus 3 plus 18 is what? It's 15. So we know this is the one, okay? So let's take that, x minus 3 times x plus 18, and let's double check it, okay? X squared plus 18x minus 3x plus minus 54. That's what that is. This times this is 54 minus 54. We found that out earlier. So now we combine these terms. X squared plus 15x minus 54. Is that the same as what we started with? It is. This is our answer. So that's the answer to the third one. And then what I recommend you do is go back to where we started this, and you can see the time up here, and get your homework, practice those homeworks, put your answers in the comments, and then we'll give you some feedback whether you got them or not right or not. But you're going to know if you got them right, because all you got to do is check them, and then we'll provide the answers and an explanation for those problems later. Thank you for watching. Hope that you learned. To the second part of the video, where we're going to explore factoring some of these expressions, these trinomials, where a does not equal 1. In this case, we're going to do an example here where a is 6, and so that brings in some extra complications. But we have this process here to be able to solve that. We're going to work a few examples before I give you some to try, and you'll be able to see how all this works. Okay? So the first thing we're going to do is we're going to find the factors of a, then we're going to find the factors of c. So we're going to find the factors of this term, then the factors of that term. Then we're going to look for the combinations of factors where this here, this equation is true. And what is this equation? This equation means that this here is a fact, these two are factors of A, okay? And so because when we multiply them together, we're going to get the x squared term. So that means these two multiply together to get A, and that's why we're going to factor A and figure out what are the factors of 6 in this case. Okay, so we're going to use F1 and F2 to represent those factors. And then we have P and Q, and that's the second term of these binomials that we're going to use. So we have a P here and a Q here. And so F2 times P is going to be the coefficient of the x term, part of the coefficient of the x term here. And F1 times Q will be the other part of the coefficient for the x term. So what we do is we do F2 times P, which is this piece, and F1 times G, which is this piece. Those have to add up to B, right here, this term. So what we're doing is we're finding out the combinations of this and the combinations of this that are going to add up to 13 when we multiply them together. And we're just going to mess with the coefficients. We don't need x in this analysis. Okay? So let's work an example so you'll understand. Okay? So the first thing we have to do is find the factors of A. So the factors of A are of 6. In this case, A is 6. The factors are 6 and 1 and 3 and 2. Okay? Now we could also have minuses. Minus 3 times minus 2 would also be a factor of 6. But when we first look at this equation, we know that this is positive and this is positive. So therefore, we don't have to look for the negative factors, okay, in this case. We'll have some where we do, but in this case we don't. So that's a nice trick. It's another trick. You want to write that down and keep it as a note when you do your problems. That trick means if this is positive and this is positive, we don't have to mess around with those negative factors, okay? And then we also could have 1 and 6 and 2 and 3 because order kind of matters, but we don't have to do that on this side if we're going to do it over here, and I'm going to pick to do it over here. So let's take that off here. So remember, you don't have to do both combinations on both sides. You only have to pick one side. We're going to do it over here. So the factors of 5 are simply 1 and 5 and 5 and 1. Okay? And I should have mentioned, and I should have checked and looked for common factors. We don't have any common factors with 6, 13, and 5, but you should always do that first. I kind of missed that. My bad. Okay, so now we have these factors. So we have to check. First, we're going to check if the factors of, if the F1 and F2 are 6 and 1, then we're going to compare it on these two to see if this equation can be solved. And then, and this equals B, okay? And then we're going to check this one in here. And once we find one that works here, we're done. We don't have to keep looking, okay? So hopefully we get lucky and we don't have to do a whole lot of work. It's hard to say which way will be. Some you have to do lots of work, some you don't. And hopefully we'll get lucky. Let's see what happens. Okay, so let's construct this. So if we take this first part and we put 6x plus p, and we take x plus q, okay? That's going to be, we're trying to figure out what p and q are. And we're going to take this first case. This is case 1, and this is case 2. Okay? Now we're going to check that against this, and we're going to check it against this. So we're going to plug those in here and see what happens. Okay? So let's derive our equation. Let's get this equation first. So p is this term, and it multiplies by f2, which is x, and this is going to be our p, and this is going to be our q. Okay? So, and this is f1, and this is f2. Okay, see that's a little bit helpful for the first couple to do. So we have p plus 6q has to equal b. Okay, so Now we check this equation here. So if P is 1 and Q is 5, does that equal, in our case, B is 13? Okay? So if this is 1 and this is 5, that's 31. That does not equal 13. So that one didn't work. Now we're going to check this one. If this is 5 and this is 6 times 1, which is 6, 5 plus 6 is 11, that's not 13. So that didn't work. So that tells us that this is not a solution. Okay? So now what we do is we erase this, we go on to the next one. And in this case, you'll do this on a single piece of paper. I don't have a ton of whiteboard space, so I'm going to just erase stuff and fill it back in with the new section here. So this is 3. That's F1. So we plug in 3. And then we have 2. Okay? So now let's write this new equation. So this is 2p. That's F2 times p, right? F2 times p. Can you see that? F2 times p plus 3 times q equals 13. Okay. So now I have to plug these in, both of them, just like we did before with this case, case 2. So if p is 1, then this becomes 2 times 1. Sorry, not 2 times 11. 2 times 1 plus 3 times 5. And that does not equal 13. Nope. Okay, so now we have to check the second one, which is 5 and 1. So 2 times 5 plus, this is 1, 3 times 1 equals 10 plus 3 equals 13. So we found our solution. Our solution is this one and this one. So this is F1 and F2, and this is P and Q. So we would write that as 3, right? We already have our equation, 3x plus P, which is 5, times x plus Q, which is 1. Okay, let's check. Now we always can check, right? So check your work. So this is where we check. So 3x squared, we FOIL it out, plus 3x. Forgot to write my 2 here. Sorry about that. Plus 3x plus 10x plus 5. If we combine these terms, we have 13x, right? So we have 3x squared. I'm sorry, I did it wrong because that should be 6x squared. My bad. Sorry about the first example being a little messy. So if this was a 2, I didn't write it in, so I accidentally wrote 3, but it is a 2, so I'm going to multiply it through. So let's do it again. 6x squared plus 3x plus 10x, which we combine to be 13x plus 5. And I think we got our answer. 6x squared plus 13x plus 5. There we go. So that's the first example. And you can see it looks a little bit complicated, but if you just methodically walk through it and get a little bit lucky. We were not lucky in this case because we had to check everything. It was our last option here. And that happens sometimes, but hopefully it won't happen on the next problem or all the problems. But it was good because we got to do extra practice. Okay, so I'm going to write up the second example and let's go through that one. Okay, now we're on to the second example. And in this second example we have b is a negative number. And so that's going to have a couple of different twists, and we're going to come up with another trick that I want you to write down and keep so that we have it, okay? So let's factor a. First thing we're going to do is check to see if there's any common factors. No common factors in here. And so we're gonna now check for the factors of a. I got 10, 1 and 5, 2, and we don't have to do the other two because we're going to do them over here. The combinations, okay? We don't have to do the negative ones because we're going to cover the negative ones over here. All right, and then now we got to find the factors of c, which I did, And if you notice, they're all negative. Now before they were all positive. Now they're all negative. Why? Well, if you think about it, we could also add all of these, the same thing down here, but all positive. But really, if we add, in this equation, if we add two positive numbers, there's no way we're going to get a negative b. So why even check them? We don't have to. So here's your trick. When this is negative and this is positive, you don't have to do the positives here. Just look for all the negative ones here. Okay? So we have a positive and a positive. When this is a sole negative number, just check the negatives. Okay? It'll save you a lot of time, make this much faster, a lot less work. All right? Now we're going to just use the same technique we used before, except we're going to use it with some negative numbers. What I like to do is we'll take this case 1 here and case 2, and then we're going to have to try it on every one of these. And there's really no way to kind of know. We have to just try it, okay? So there's a little trial by error, but we're doing it in a more scientific way where we're trying to eliminate some of the options we have to check. All right, so let's start off with our binomials. We have 10x and x, okay? And then we have plus q and plus, we have plus p and plus q, all right? And so now we can get this formula, and we have p times 1 plus 10q equals minus 19. All right, so now we have to start checking combinations. So if you look, minus 6 times, so if you remember, we did it like this. We went like this. We said this was P and this was Q. We went like this, and we said this was F1 and F2. And that can help you, and you can do that if you want to. So when we put in minus 1 here, plus minus 6 times 10, that's minus 60. No way, that's not 19. This one might be interesting. So minus 2 times minus 2 plus minus 30? No. Minus 6 plus minus 10, minus 16. That's a little closer. Minus 3, minus 20. That's not it. So none of these worked. So we know that this guy here is not a solution. Okay? So now we have to get rid of this. Get rid of this coefficient. And in your paper, you just keep writing down, but I don't have anywhere to write, so I'm erasing and redoing it. It'll be faster if you just keep going. And now we have to not do this one, but we have to check this one across all these, right? All right. So we have 5. We have 2. Now we have to derive our equation. F2 times P is 2P. Plus F1 times Q is 5Q. And what does that equal? It equals B, which is minus 19. All right, so let's start checking. Minus 2 plus minus 30, that's not going to be minus 19. This would be minus 4, right? 2 times minus 2, that's minus 4, plus 5 times minus 3. That is minus 15. Minus 15 plus minus 4 equals what? Minus 19. So we found it. It's this one. And it's this one. Okay? So we don't have to check the other two. So we kind of got a little bit lucky, which was okay. Oh, we didn't have to check them all like last time. All right. So this is our equation now. We're going to have 5x plus p, and what was p? Minus 2. So this will be 5x minus 2 times 2x. What was q? Minus 3. So we just put minus 3. Let's check our work. Remember? Check your work. 10x squared minus 15x minus 4x plus 6. These two combine to be minus 19x, and we have our answer. 10x squared minus 19x plus 6, same as our original equation, and so we were able to solve this one pretty quick. And let's remember, if this term is negative by itself and these both are positive, just check the negative factors of c. Okay? That was the trick. That's our second example. Let me get this third one set up and we'll look through that one. Okay, for our third example, we have 3x squared minus 10x minus 8. We have 3 and 1 as the factors of 3, but minus 8, since it's negative, it has a lot because we have to check both the order because these are different, right? We have to check the order that they might happen in the equation. So, for example, we have 2 and minus 4, that's a factor of minus 8, and so is minus 4 and 2. We have to check that combination. We're going to walk through all these, and this is one of those cases where we hope we get lucky because that's a lot of work to do. So we'll start out by setting up our equation. Initially we only have one combination for A, so that's good. And that's Q and this is P, right? Okay, so now based on this we set up this equation and we have P plus 3Q equals minus 10. All right, so let's start checking our combinations. We have 2, remember this is P, this is P, and this is Q. Okay, so we have 2 plus 3 times minus 4 equals minus 10. You know, we don't know if it does, let's check. So 2 minus 12 equals minus 10, and that does equal minus 10. So we finally got lucky and we got it the first time, so that's great. So 3x minus, let's see, plus 2 times x minus 4. That's what those are. There's Q over here. So we have 3x, let's double check our math. 3x squared minus 12x plus 10x minus 8. Right? And so we can combine this and this is 2x, sorry, plus 2x. This combines to 10x. All right, so we have 3x squared minus 10x minus 8. That's our original equation. So this is our answer. All right, so now you've seen 3 different equations, 3 different things, 3 different examples, and we got lucky on this one. We only had to check 1 versus almost 8 different checks. So we got it that early, and now we'll go on to the problems that you can do for time. Okay, now is the challenge section, and we're going to ask you to do these 3 problems in 12 minutes. It's more important that you get them right than you get them fast. But if you can get them right and fast, that's going to be really good. So take a crack at these problems. What I'd like you to do is pause the video, use your phone, a timer, the timer on your phone, a stopwatch, whatever works for you, and try to finish these in about 4 minutes apiece. If you can do that, you're really doing well. But again, let's try to get them right versus get them fast. So go ahead and do that. You can pause the video now. When you're done with these 3, come on back, and then we'll go through each one. Welcome back. I hope you had a successful little assignment here and that you got the same answers as I did. I hope you did it in 12 minutes. It's not important that you do it on time. It would be a good benchmark, but most importantly, did you get the answers right? If you didn't get them right, then you're going to want to stick around and pick and fast forward to whichever is appropriate, whichever part of the video is appropriate for your problem that you missed. If you missed them all, then watch it all, okay? And then here's your homework once again. This one's a pretty challenging problem. If you get that one right, you're really in good shape. Try to do these in about 4 minutes apiece. So if you can finish all these in 20 minutes, that'd be fantastic. you'll be on your way for some really good test results, and you'll do well going forward. You'll see that some of this stuff becomes second nature as you do it, and so that's what that's why we practice. We have to practice to become really proficient, be able to see these, limit the combinations down, and really work on the problem. So hope you enjoyed this. I will put the answers to the homework in the comments later on, but I want to see your answers first. So please post those, and we'll see you in the next video. Thanks a lot. So we got this, and now we have -9 and -7 and -7 and -9. And that's all the factors, okay? So again, this is P, this is Q. All right, so let's write our equation. First of all, we write our factors, 2x plus P times x plus Q. All right, that's good. Now we have P plus 2Q equals what? Equals -25. All right, so now we have to check all these combinations to see what's going to satisfy this equation. Remember, we just used this formula here, 2 times Q, that's F1 times Q, F1 times Q, and we did F2 times P, F2 times P. So we have P plus 2Q equals -25. Now, let's put this here so you don't get confused. Now let's start checking. So I could tell right away that -63 in this thing is never going to be -25. So we can just take those out quickly, right? Because -63 minus 2 is -65. That's way too high, and this is 2 times -63, so that's way too high. It's going to be one of these. Let's figure out which one. So -9 plus 2 -7 times 2, that's -14. -9 plus -14, that does not equal -25. Okay, so it's not this one. Now -7 plus 2 times -9, that's -18. -7 plus, or -7 minus 18, or plus or minus 18, that equals -25. So we found it. So it's the last one. We got a little bit unlucky. Had to do a little extra work. We have 2x minus 7 times x minus 9. Okay, so 2x squared minus 18x. We're doing our check now. Minus 7x plus 63. Is, that's the answer. So 2x squared minus 25x plus 63. There we go. We got our original equation. And so this is the answer to problem number 1 that you worked on. Our second example, we're going to use the same method. We know a is not equal to 1. We look for our common factors. We don't have any. And there is a trick on this one. Watch till the end, because I'm going to give you a really good trick that'll save you tons of time. But we're going to work through it the hard way first, and then I'm going to show you the trick. Okay? So 16w plus 24w plus 9. We got to find the factors of 16. It's going to be 1 and 16, 2 and 8, and 4 and 4. Okay? So we got 3 on that side. And now we got to find the factors of 9. And we notice, okay, I forgot to talk about this. That's a positive. So we don't have to check the minus, just like we didn't have to check it on the second example. Because if we add with this equation, these are 2 minuses, we'll never get a positive number. So we don't have to check the 2 minuses. It could be like a -3 and a -3 for the 9. We don't have to check that, because that's a positive. All right. So that simplifies our work a little bit. So we're going to have 1 and 9. We're going to have 9 and 1. We have to check both. And then we're going to have 3 and 3. And that's it. So we got 3 of these and 3 of these. This is P. This is Q. This is F1 and this is F2. Okay, so let's take the first one and write our equation. We have x plus p times 16x plus q. Okay, that's a 16. And I said x, and that's a habit. I wanted to point out that we don't always have to work in x. We can work in any variable. And I'm used to doing it, so I messed up. But that's this is w in our case, okay? So we have w and w. All right. So now we've come up with our equation. We take this, we have 16p plus q equals 24. Okay, so now we have to start checking these. Or on this one, we're going to check each of these. Okay, so the first one is 9. So we have 16 times 1 plus 9. That's close to 24, but it's not 24, it's 25. So that's not it. All right, now we'll check the second one. 16 times 9 plus anything is going to be greater than 24, so we know that's not it. And 3 times 16 is way bigger than 24, so that's not it. So we rule out this one. So now we can erase those, we can erase this. And again, on your piece of paper, you just keep rolling down, but we have to kind of mess all this up because I don't have a lot of space, all right? Take out the 16, and then let's figure out the next one. This is 2, this is 8. We have to get our equation, so it's 8p plus 2q equals 24. All right, so if this is 1, then that's 8, and this would be 2 times 9 is 18. 8 plus 18 equals what? It equals 26. We didn't get there, so that's not it. So this one's not it. Now we have 9 here, that's 72. Automatically, that's not it. And if this is 3, then that's 24. Add anything to 24, we don't have 24. So therefore, that's not the second one either. So we're into the last one. All right. So we know it's going to be 4, 4. That's good. At least we found that part of it. So now we have a 4 and a 4. All right. So that means this is going to be 4p, and this is going to be 4q. All right, and that has to equal 24. So 9 times 4 in either one of these combinations is either going to be p or q. That's a bigger number than 24, so those are not it. And then 3 times 4 is 12, and 3 times 4 is 12, and that equals 24. So we found it. We got unlucky again. It's the last one, but we found it. And we have 4 times w plus 3 times 4 times w plus 3. So look at that. This is 4w plus 3 squared. And that's our answer. That's our factors. Okay? And we could double check. We could look, 4 times 4w is 16w squared plus 12w. I'm sorry, 16w squared plus 12w plus 12w. That's 24w plus 9. So that is the answer. But what I want to show you, which is interesting about this, let me use a different color. I'm going to use green. What do we notice about this number and this number? Well, if I square that number, it's 16, because I have this square, right? So when I square it, it's going to get 16. Look at that. That's 16. And if I square that one, I get 9. And look at that. That's 9. So if A and C are perfect squares, and this is the perfect square of 4, this is the perfect square of 3, we could quickly write this as 4x plus 3. This one goes here, this one goes here, and then square it. And that's a factor there. These are perfect squares, so this is a perfect square. So you could quickly get this if you see it on a test or you have another problem like that. When you have the perfect squares, you can write it that quick. You can solve it that fast. Okay, so that's another trick. So write that one down. Look for those perfect squares in the ends. Doesn't happen very often, but once in a while it does, and then it's a real quick answer. You don't have to go through all this. You can just solve it just like that. All right, let's go on to the third one. Welcome back. Okay, now we're going to look at problem number 3. In this case, we have 24x squared minus 22x plus 5. We notice that the b coefficient is negative, so that tells us that we're going to need to use just negative numbers here because this is positive. And then we know that f1 is going to have, and f2 are going to have 4 combinations to get the factors of 24. And so we have to check 4 against 2. So let's get started. So I'm going to work in this area here. We'll take our first one here. We know it's x. So let me just draw this so I don't have to keep erasing it. We'll go x plus p, and then 24x plus q. Okay? So we do this. We have 24p plus q equals minus 22. And this is just using this formula here like we've done every time and breaking this down and looking across here. Okay, so now we have to check 2 cases here. We have minus 24 minus 5. That's not minus 22. And then we have minus 120 minus 1, and that's not minus 22. So this one is out. Now we rewrite our equation. Okay, rewrite that equation. A little messy there. And that will be 2 and 12. So we have 2 and 12. And then we have 12p plus 2q equals minus 22. So if we look at this one, it's a minus 12, right? Minus 1 times 12 is minus 12. And this is a 5, that's minus 10. So we have minus 12 plus minus 10, and that equals minus 22. So we found it. So it's this one and this one. Okay? So let's write our equation. 2x plus, or I'm sorry, minus 1 times 12x minus 5. So let's check it. 12, this is 24x squared minus 10x minus 12x plus 5. So that's minus 22x. And so we have 24x squared minus 22x plus 5. 24x squared minus 22x plus 5. So that is our answer. We got it. All right, so you can see we got a little bit lucky. We didn't have to check these 2. We hit it on the second term and we only had 2 on that side, so that was a nice little problem. So there we go. We used our quick trick with the negative. We knew these were going to be negative because that's positive, so we knew we were going to take the negative terms, and then we had to work out the factors of 24, which wasn't too bad. So we got all 3 of these. Now what you're going to want to do is go back to the homework that we assigned, and if you go back to the video at this place here, you'll have the homework, and then you can go work those out. I think we said it was 4 minutes a problem. Try that, put your answers in the comments, and then we will put our answers in. You know, you can check your answer. Remember, check your work, just like we did here. You shouldn't need to go back there, but if you run into trouble and you want to find out the answer, they'll be there for you. But post your answers there so we know you worked on it, okay? So thanks a lot, and we'll see you on the next video.